Alright guys, this is the second video of section 7.1, and this one's quite a bit easier and quite a bit shorter. So before we talked about the interior angles of polygons, now we're going to talk about the exterior angles of polygons. Now exterior angle of polygons is a little different because if you remember the interior angles, the sum of the interior angles would change depending on how many vertices or how many sides the figure had. So for example, a triangle, the interior angles would be different, the sum of the interior angles would be different than a hexagon, which would be different than a decagon, which would be different than a 73-sided polygon. So all of those are different. The cool thing about exterior angles is that they always equal 360. It doesn't matter how many sides or angles they have, exterior angles always equal to 360. All right, so if we look at example number 1, okay, this is an exterior angle, this is an exterior angle, this is an exterior angle, and this is an exterior angle. And this theorem here tells us that if we add up all of these exterior angles, they would equal to 360 degrees. So let's do it. So 89 plus 67 plus x plus 2x equals 360. Okay, now we've taken a geometry problem and we have turned it into an algebra problem. So 89 plus 67 is 156 plus x plus 2x is 3x equals 360. So 360 minus 156 minus 156, I get 3x equals 204. Divide both sides by 3. I get x equals 68. That is the value of x. Of course, it asks for the value of x. If it would have asked for the measure of the angles, we would have just plugged x in here and here to get those. All right, let's look at example 2 now. Okay, the trampoline shown is shaped like a regular dodecagon. So here's two vocabulary words side by side. If you don't know what one or both of these are, and this is on a test, you're not going to solve this problem. Okay, so I want you to ask yourself, what does it mean to be regular? What does it mean to be a dodecagon? And then put those together, and what does it mean to be a regular dodecagon? Okay, well, regular means all the sides have the same length and all the angles have the same measure. And then dodecagon tells me that we have 12 sides. Okay, so the first thing we want to do is find the measure of each interior angle. Okay, it doesn't say the sum of all the interior angles, it says each interior angle. All right, now in order to do this, I first have to find the sum of all the interior angles. Okay, so remember, n times 2 times 180, our n is 12. So 12 minus 2 times 180. Okay, well 12 minus 2 is 10 times 180. 10 times 180 is 1800. So if I add all 12 of these interior angles, it would give me 1800 degrees. Okay, but I don't want all of the angles. I want just this angle, or just this angle, or just this angle, just this angle. But knowing that it's a regular dodecagon, each of these 12 angles are all the same. Okay, so I want to divide this 1800 equally among 12 angles. And when I do that, I get that each angle is 150 degrees. All right, let's look at B. Now it says find the measure of each meaning one, exterior angle. Well, guys, this is a lot easier because we know that all the exterior angles add up to 360 degrees. And this is a regular dodecagon, which means that every exterior angle is the same. So divide 360 by 12, and I get 30 degrees. Now, notice when I compare the interior and the exterior, these are supplementary. They always will be supplementary. Okay, now think of it. If you have a figure here, like that goes all the way around, whatever, Here's the interior angle. Here's the exterior angle. These are always a linear pair. So interior and exterior at the same angle will always be supplementary. All right, I want you to go through this figure and fill out this chart in its entirety. Just by given the few things you have, you can find every interior and every exterior angle measure here. All right, guys, here's what you should have gotten. So angle B was the hard one. You'd have to do that last. But each one of these pairs add to 180, add to 180, add to 180. All of these add to 180 degrees. Okay, so that's how you find all of these. Then when you get to B, you can do one of two things. You could either solve for the exterior or solve for the interior measure. Now, I did the exterior just because I know it's easy. All the exterior angles, so this whole column has to add to 360. So that's what I did. Here's my work for that right here. So I found that the missing exterior angle had to be 74 degrees, and then 180 minus 74 gave me 106 for the interior. Now, when I was done, just to kind of double check myself, I went and I added up all of these, and they summed to 720, okay? And then I did find out that the n minus 2 times 180, so this is a hexagon, is 720. So check mark, we're right.